Swayam Prabha. Digital India. Educated India.
Friends, today we shall be discussing on the characteristic of gradually varied flow. Well, in the last class we have discussed how we can classify gradually varied flow, and then we just started discussion on characteristic of gradually varied flow. Well, before going to characteristic of gradually varied flow, let us summarize what we did in our last class so that we can go in a more convincing way to the characteristic of gradually varied flow. Well, in the last class we started with the classification of gradually varied flow. Well, and we could see that how we classify the gradually varied flow. First, for classifying gradually varied flow, we do it on the basis of the slope on which the flow is occurring, and then we divided the zone, the flow zone above the bed into three different zones, zone 1, zone 2 and zone 3, and based on the zone on which this particular flow is occurring, based on that we classify. That means we classify on the basis of slope as well as on the zone. So, slope means again there were different type of slope. Say it can be mild slope. Mild slope means when the bed slope is less than critical slope. Well, and then it can be steep slope, means the slope is steeper than critical slope, and then again critical slope. Of course, critical slope means when the uniform flow occur for a particular discharge in that particular section, that particular channel, uniform flow occur at critical depth. So, that particular slope we call as a critical slope. And then of course, we got that flow can be there, gradually varied flow can be there over a horizontal bed also. So, and then over adverse slope, say slope is in negative direction. Negative direction means slope is, bed slope is not falling in the direction of flow, rather it is rising in the direction of flow. So, that sort of slope we referred as adverse slope. So, in that process again zone 1, zone 2, zone 3 are always there, that we did discuss elaborately in the last class. So, by that process we could classify the channel, we could classify the gradually varied flow profile into 12 different classes and 12 different type, that you can see that these were M1, M2, M3, then it was S1, S2, S3, and then we had for critical slope we have C1 and C2. And why C, well sorry, here it should be C3. We had C1 and C3, and why the C2 is not existing? Because the zone 2 is not existing in case of critical slope, because normal depth line and critical depth line coincide in case of critical slope. So, that zone itself is not existing. So, the profiles are C1 and C3. Then in case of horizontal slope, we got horizontal bed rather, we got H2 and H3. Here H1 is not existing because the depth of uniform flow in case of horizontal slope is at infinity. So, we do not have the zone 1 which cannot be there beyond infinity. Well, so that way we had only H2 and H3 profile, and similarly in adverse slope we had again A2 and A3 profile. Here also A1 is not existing. The reason is that the uniform flow depth in case of adverse slope is imaginary. So, we cannot have anything when we do not know about the exact location of yn, it is an imaginary depth. So, beyond this we cannot have any other zone. So, that way we do not have the A1 profile, right. So, we had A2 and A3 profile, and these are the 12 different types of gradually varied flow profile that can occur in nature. And of course, these profiles, if the slope in the nature keep on changing, definitely it will keep on changing when a river is flowing, then we can get combination of different type of flow profile, and that combined profile actually give us the water surface profile in a natural channel. Well, with that we can now go on to the characteristic of gradually varied flow. Well, you can concentrate into the slide that we have derived the governing equation already. That governing equation is dy dx is equal to, that can be expressed in this form, Sb, then 1 minus Sf by Sb, then 1 minus q square t by Ga q. So, this way the governing equation we could derive. Of course, it has different form, and as we explained in the last class, for analyzing characteristic of different types of profile, we can have this form in a more simpler way, and in terms of the normal depth of flow, critical depth of flow, and the depth of gradually varied flow at any section. So, and that we can achieve by considering the channel to be wide rectangular channel, and we did discuss in the last class that governing equation for wide rectangular channel, using Chase's equation as resistance formula, we could get the equation in this form, that is dy dx is equal to Sb into 1 minus yn by y whole cube divided by 1 minus yc by y whole cube, where yc is the critical depth, yn is the normal depth, and y is depth at any section within the gradually varied flow portion actual water surface depth. So, that way and Sb is the bed slope, Sb is the bed slope. Well, and starting from this equation, now we can see how the characteristic of M1 profile can be determined. Of course, if we just think what we did in the last class, we could at least establish that M1 profile is a rising profile, that we have already established. Okay. And well, just to recall that, say dy dx is equal to Sb into 1 minus yn by y whole cube divided by 1 minus yc by y whole cube. Well, that is the equation, and in case of mild profile, that is mild slope, our CDL line is here, NDL line is here. Well, so it means that critical depth is this one yc, normal depth is yn, and suppose profile is here in zone 1 because it is M1, so it is in zone 1. So, depth at any section is say y, and as such we get that y is greater than yn, that is the normal depth at any section of the gradually varied flow portion, and yn is greater than yc. So, that we could get. And then if it is like that, that means this ratio yn by y, this is becoming fraction, yn is smaller than y. So, this is becoming fraction, cube of the fraction is definitely less than 1, 1 minus something less than 1 is positive. Here also yc by y being greater than yc, this is also a fraction, and that cube of the fraction will be definitely a fraction, and 1 minus something less than 1, which is a fraction. So, that is also therefore positive. So, numerator and denominator both are positive, and when it is mild slope means base slope is also positive. We talk about negative base slope only when we talk about adverse slope. Slope falling in the direction of flow we refer as positive slope. That we emphasize when we were doing derivation of the gradually varied flow. Perhaps you remember that, and that is why this SB is also positive, and this means that dy dx, that is the change of y with respect to x. Say depth here is y, here is suppose y1, then change of y with respect to x, x is this direction, is positive, means it is a rising profile. So, this will always be positive. If it is negative, then only it will be a falling profile. Say this is y1 minus y. So, this suppose y1 minus y, if this distance is delta x, then this rate is y1 minus y divided by delta x. Like that also we can write if we want to discretize that. But anyway, this dy dx positive means it is a rising profile, and based on that, actually in the last class we got this statement that mild slope m and zone 1, the profile we get is m1, and this is a rising profile. Well, now let us go further into the characteristic of m1 profile, and what are the other things that we need to study. Well, now we have seen that it is a rising profile. So, if I draw this line, say this is normal depth line, okay, this is normal depth line NDL, well, and then it is a rising profile. So, it will be rising like this, and CDL line will be of course here, that we may not draw right now, but well, let it be here, and this is the bed. Now, as it is rising profile means this profile, if we see on the upstream side, this will gradually fall, and to what extent it will come? It will be coming to the NDL line, that is at extreme upstream, starting of the gradually varied flow profile. We can call that this is the starting of the gradually varied flow profile, this point, this section, and from here suppose it is rising, but at upstream end, extreme upstream end, we are getting that y is equal to y n, that is normal depth and the depth of profile is equal. That is bound to be, because it is coming down like that. Now, if it is the situation, let us see what will happen at the upstream end. So, at upstream end of the gradually varied flow profile. So, what we are getting, that y is, of course, we should not say that y is exactly equal to yn, because if we say that y is exactly equal to yn normal depth, then it is a uniform flow. So, we can call that y tends to yn, y tends to yn, almost equal to yn. Now, if this is the situation, then what will happen to this equation? dy dx, what will happen to dy dx? It is equal to SB, then 1 minus yn by y whole cube divided by 1 minus yc by y whole cube. Now, in this part, as we can see that when yn and y are almost equal, then this ratio, when y tends to yn, this ratio become 1. This ratio will become 1 in the numerator, and that is why this numerator part, that is 1 minus 1. So, this will become 0, 1 minus 1, that will become 0. So, what we can write, and once this part becomes 0, whatever may be the other value, this part is of course positive as we could see, but whatever may be the value of SB, so these are not coming into question. So, what we are getting, that dy dx is equal to 0, dy dx is equal to 0. So, at upstream end we are getting that there is no change of y with respect to x, there is no change of y with respect to x, and we already got that in uniform flow itself y is not changing with x. So, it is meeting the point at the end, and just when it will gradually, suppose we are increasing the y value, the slope wise, dy dx is 0 here, and dy dx 0 means this gradually varied flow line will meet the normal depth line asymptotically. So, y tends to become yn asymptotically, that is we can say from this particular value, that is dy dx equal to 0. Well, so this is one characteristic of M1 profile, that at upstream end the depth rises very slowly, because the depth is, that is the gradually varied flow line is meeting the yn asymptotically. So, it will be increasing very slowly, and that is why the length of M1 profile is quite large, length of because it will take lot of time to meet the yn or the uniform flow depth. Well, then at downstream point what will happen? At downstream point, of course, this is it is rising like this, then to what extent it will keep on rising? In fact, when we get M1 profile, then it is above normal depth. So, normally the flow cannot rise or cannot go beyond the normal depth line, or it cannot exceed. So, there must be some obstruction like that, there must be some obstruction or barrier or something must be there which has caused the water to rise, So, it is rising like that, and then when it will cross this barrier, it will definitely fall on the downstream side. Of course, what will happen on downstream, right now we are not concerned about that, but we are concerned about what will be the case in the extreme right hand side. Right hand side means basically not right hand side, it is the downstream side, extreme downstream side. So, this section, this sort of obstruction or say artificial structures that are constructed in the river, or sometimes we can have some natural barrier also, we can sometimes have some natural barrier also like that. Sometimes we can have say rock outcrop which can restrict the flow zone, and that can also lead to this sort of situation or different sort of situation. Well, so whether it is natural or artificial, point is that that sort of structures or section we refer as control section. That means at that section there is a definite relationship between the discharge and the depth. Well, we will be coming to that later when we will be discussing unsteady flow, then it will be more relevant discussing that part. But anyway, here also we will be discussing it briefly, and at this point, that means depth of control section we can call, here is the depth of control section. So, at the downstream point we will be getting y equal to say y control at the downstream point. Of course, when it is a series of profile, then that depth may be governed by what is happening at the downstream end. So, like that different other situations may come, but at upstream we are very much sure that it will be equal to yn, and it will be just tends to become yn asymptotically, and at downstream point the control section depth will be defining the depth of flow profile, and in between from here to here, the flow profile is a rising profile. This will be a rising profile and the shape of the profile, what will be the shape of the profile? That will be governed by the equation dy dx, this equation. Well, if it is other type of channel section, then we can go for the general governing equation of the open channel flow, I mean gradually varied flow. And well, so then let us see what will happen to the M2 profile. Well, before that, when we are just getting at the upstream point, dy dx equal to 0 means y is not changing with x. Well, but this dy dx equal to 0 generally can give us a feeling that the profile is becoming horizontal, because dy dx represent the slopes, and when we say that dy dx is 0, that feelings may come to our mind that the profile is becoming horizontal, but that is not correct, because here our y, that is depth, we are measuring with respect to channel bottom, not with respect to a horizontal datum. We are not measuring with respect to a horizontal datum. So when we are saying that dy dx is equal to 0 means depth with respect to channel bed is not changing, depth of flow is not changing, rather with the direction of x. So it will become parallel to the bed, not horizontal, it will become parallel to the bed at upstream end. Okay. Then let us see what will happen to the M2 profile. In M2 profile, this condition remains same. Okay. In practical situation, when we can have M2 profile, that of course different conditions we can have, but this CDL and the NDL, normal depth line, NDL, this will be there. And suppose there is a drop, something like that, canal drop, and say water was flowing from this point, and then it can come, it will come down. Okay, whether it will come down, that we will just get from our mathematical expression, but right at this moment we can say M2 means it is something here, M2 means it is something here. So say Yn is this depth, Yn, Yc is this depth, and then depth of flow y. Right now I am drawing it in the drawdown shape or in the downward direction, because I know that, otherwise we need to prove it mathematically. Okay. Well, that y, let this be the depth, and what the condition we are getting in M2 profile, the condition we are getting is that Yn is greater than y, that means this, because the profile will always be between Yn and Yc, so y is bound to be less than Yn, but it is again greater than this y, depth y is always greater than Yc, because the lowest limit of the M2 profile is, or rather we can say the lowest limit of the zone 2 itself is the critical depth line. Well, so Yn is greater than y, and this is greater than critical depth Yc. Now if we refer the same equation, that is dy dx is equal to Sb into 1 minus Yn by y whole cube divided by 1 minus Yc by y whole cube. Let us refer the same equation. Well, and here also as it is mild slope, so Sb is positive, Sb is less than Sc, but it is positive, it is positive. Well, now when if we see the numerator, then we can see that Yn is greater than y. So this ratio Yn by y will be greater than 1, Yn by y will be greater than 1, and then cube of that will be of course when 1.17 to the power cube, it will be also greater than 1. So, this ratio is always greater than 1. Then 1 minus, you can concentrate on the slide, then 1 minus this ratio which is greater than 1 will lead to negative value of the numerator. So, what we can say that numerator become negative. And what about the denominator? That you can see that yc is less than y, yc is less than y. So, this part again become fraction, and cube of that fraction will always be a smaller than 1 term. So, that way 1 minus smaller than 1 will lead to some positive value. So, that way this ratio 1 is negative on the top numerator and this denominator is positive. So, negative by positive, and this SB is positive, SB is positive. That way dy dx we are getting that this is equal to negative, whatever may be the value, but this is equal to negative. So, dy dx negative means, this implies that the profile is a falling profile. So, depth y is falling with respect to x, it is decreasing with respect to x. So, in the direction, x means the direction of flow definitely, and so with the direction of flow the depth is decreasing, and that is why this profile now I can draw more confidently that it is like this.